Hello everyone, welcome to 1045 Engineering. Welcome to the series Grind 75, a better blind 75. So today we are on our third problem out of the 75s, merge two sorted lists. So we are given two sorted lists and we have to merge them into one and return the head of the merged linked list. We are going to solve this in the time complexity of O of n. So let's head towards the problem statement and start solving. Okay, so last time we had solved the valid parentheses as well. So in grind 75 we are marking one by one the problems that are getting solved. You can actually see them in the YouTube list as well on my channel. So sum has already been solved, valid parentheses has been solved, and now today we are starting with merge two sorted list. Okay, so let's quickly understand the question. You're given two heads of two sorted linked lists, list 1, list 2. Merge the two lists into one sorted list. This list should be made by splicing together the nodes of the first two lists. Return the head of the merged linked list. Okay, pretty straightforward. So we can see we have two lists 1, 2, 4 and 1, 2, 3. Sorry, 1, 3, 4. So the end list would be 1, 1, 2, 3, 4, 4. Right? 1, 1, 2, 3, 4, 4. So the approach, I would suggest to pause here and think of an approach that we are going to take. Okay, so approach wise it is pretty simple. We put a pointer on each of the nodes, which let's say I'm checking for this one 1 1. Okay, so right now I can pick any one of them. So I pick this one as 1. Then I compare 3 with 1, 3 against 1. So 1 is smaller, so again 1. Then I compare 2 against 3, 2 is smaller, so 2 goes as part of the list. Then I compare 3 against 4. 3 is smaller, 3 goes as part of the list. Then I compare 4 against 4 and 4 is smaller, 4 goes as part of the list, and then the last 4 goes as part of the list. But let's say in case this list contain 1, 2, 3, 4 and then 1, 2, 4 and then 5, 6, 7, 8. So after three comparisons or after few comparisons we have included the numbers from both the list up till 4. After that there is 5, 6, 7, 8. So if after comparison, if any of the list is still has more elements into it, we'll directly put them at the end of the current node. So 4, 5, 6, 7, 8. Right? Just to understand with a quick example, let's say one list was 1, 2, 4, 4, 6, 7, 8, and the other list was 1, 3, 4. So this part is 1, 3, 4 is same as this 1, 3, 4. 1, 2, 4 is same as 1, 2, 4. So resultant list would be 1, 1, 2, 3, 4, 4. So up till here we covered this list. We covered this list up till here. After this we see still elements are available in our first list. So we'll just directly put all the elements as part of our final list. So it will be 6, 7 and 8. Simple. Let's try solving this. Okay, let's first we'll create a new linked list. Okay, let's create a new list node to store the final to store the merged list, so that in the end this is another list. We would like to create another list and store all the elements and point all the elements from the earlier two lists into this one. Okay, semicolon is not required here, but okay, let's start. So let's say list node. So right now we are creating a node, list node, because, and why list node class is already specified here, a node class which has values like 1, 2 or any element value. Next, as you are aware, is points to the next node, and this is a constructor, and then we can provide the value to it. Okay, we are simply going to create an object of list node. Let's call it list equal to new list node. So this is going to be our final solution. Let's create another list node for the traversal. If you have worked with linked lists previously, you are aware that we create a temp node to traverse through the list and then assign it back. It's easier this way. So temp new list node. So now we have two list nodes, right? What we will do is let's first initialize our list with a temporary node. Okay, so we'll say list equal to temp. That means this list is right now pointing to temp. Right now both of them are blank, they are not doing much. Let's move forward. Now one by one we are going to iterate through both of these lists, and we already have the nodes, node 1, node 2, list 1, list 2, right? So we'll say iterate while both list 1 and list 2 are not empty. Why not empty? Because see, as in this case we have seen, if one of the lists gets empty, we stop this comparison, because then all the elements from the next list will directly come as part of our solution. So up till both the lists are non-empty, we'll run through this iteration. Let's put a while loop to go through the list iterations. So list 1 not equal to null, so that we have not reached the end of the list. Okay, and similarly list 2 is not equal to null, right? Now one by one we are going to compare the values. How can we compare the values? We'll use a simple if condition. List 1 dot val is less than list 2 dot val. So we are saying if this value, we are considering this as list 1, if this is less than list 2 value. Why list 1 dot val? Because if you see, both of them are list node objects, so val provides the value, that is the name of the variable that they have given. Okay, so if the value, okay, if the value in the list 1 is smaller, what does it mean? If this value is smaller, this should be part of the list, right? This should be the first element in the list. What we'll do, we'll just simply add it to the merged list. Merged, merged, merged list, you know? So if whichever element is smaller, we'll add it to the merged list. So now we'll say temp. Temp is our node that we are using to pass through both the lists. We'll simply point temp dot next towards list 1. Okay, and we'll say list 1 equal to list 1 dot next. So we let's say we have taken the first element from this list, 1 is taken here. For next comparison, we'll move list 1 to the next element, 2. So list 1 will now be pointing towards 2, and list 2 is still pointing at 1, right? We'll say temp is equal to temp dot next, right? So temp was here at the first level, we got one value, we compared it, and now temp moves to next element. Simple. Okay, I'll say for the else case, so else case would be that the other element in second list is smaller, right? I'll quickly write this in the comment section for everyone. If the value in list 2 is smaller, add it to the, or in fact, you know, not just for smaller, even if it is equal to or equal, because 1 and 1, even if 1 and 1 are equal, we can pick elements from either of the lists. Right now we are going with the case that we'll pick the element from the second list if it is equal. If it is smaller, still we'll pick it from the second list. So when we compare it, list 1 dot value is less than list 2 dot value, 1 and 1 were equal, so no. So we went to second part, and where we are comparing, where we will compare, even if they are equal, pick from here. If this is smaller, pick from second list only. Okay, we'll add it to the merged list as done for the earlier use case as well. So we'll simply say temp dot next is equal to list 2. Okay, so we started the temp right now if we go through the flow, list 1 dot value, which is this one, is less than list 2 dot value? No. So we come to else case. Now in else case, we so else case would mean even if it is smaller or equal to. So we'll say temp dot next equal to list 2. So temp is going to point to first element in the list of list 2, which is 1. So we have taken 1 here, right? And then we'll say list 2 equal to list 2 dot next. So since one element has already been taken from here, we'll move it forward to the next element. So the next comparison would be between 1 and 3. And simply temp will move forward as well because it already received one element. Temp is equal to temp dot next. Simple. If let's say after all this comparison, okay, if after all this comparison, if either list 1 or list 2 is not empty, that means there are elements left in the list, like this use case, add it to the merged list. We'll simply add it to the merged list. So in the end, we'll say so temp was here 1, then temp was temp covered this one, so this is covered 2, this is covered 3, this 3 is covered 4, this 4 is covered 4, this 4 is covered. After that we see there are still elements in the first list, so we simply can say temp dot next points toward whichever list has elements left. So after this we point towards 6, and 6 already points towards 7, 8, so 6, 7, 8, right? This we can simply do it this way. We'll say temp dot next is equal to, we'll check which list is empty. List 1 is not equal to null. Okay, we are using, so if list 1 is not equal to null, so that list 1 is not empty still, that means we'll assign it to list 1, otherwise we'll assign it to list 2. Okay, makes sense. Then in the end we'll simply say return list dot next. Now why list dot next? Because temp has reached till the end of the list. We want to return the head. Where do we get this head from? So if we go up, we already pointed our list to the first temp, so that when temp was here, so list is already pointing towards the head when temp was not even here, temp was before this, so list was already pointing towards temp pointed towards this first one, so we are saying list dot next. That means temp dot first next that we had. Make sense? Let me clarify it for you. So when we started with the temp nodes here, you can see it was not pointing anywhere, list was not pointing anywhere, we just mentioned list to point towards temp, right? Then we said temp dot next, whichever conditions comes true, is equal to list 2. So temp started pointing towards this one, temp dot next. Now this one is first part of our final merged list, so we want to return the head of our final merged list. So how will we return? We'll return list dot next, because temp started with temp dot next. Okay, let's quickly do our dry run. Okay, so we come from here, while list 1 is not equal to null, that is true, list 1 is not equal to null. List 2 is not equal to null, that is true, list 2 is not equal to null. Temp is equal to temp dot next is equal to list 1, so temp will point temp next will point towards 1 from the first list. But before that we are checking list 1 dot value is less than list 2 dot value, 1 is less than this one, no. So we come to else case. So else case we are saying temp dot next is equal to list 2, so temp points towards second list node, that is this one. Then list 2 is equal to list 2 dot next, so this moves till 1 from 1 to 3. Temp is equal to temp dot next, so temp was earlier before this, and now temp has moved here to 1. Okay, Then while loop is still running, we again check list1 dot value, which is 1, is less than list2 dot value, which is 3. Right, that is true. So we say temp dot next is equal to list1. So 1's next would be coming from list1, 1. And we say temp is equal to temp dot next. So temp was here, temp moves to temp dot next. So that next time we'll jump in next direction. Okay. Similarly, we are saying list1 is equal to list1 dot next. So 1 moves from 1 to 2. Now again this iteration runs. We check list1 dot value, which is 2, is less than list2 dot value, which is 3. That is correct. So we enter the first loop, temp dot next is equal to list1. So temp is here, its next node would be coming from first list, that is 2. Then list1 is equal to list1 dot next. So 2 moves to 4, and temp is equal to temp dot next. So temp moves to 2. Similarly, when we run forward, we do this comparison again. Now we say list1 dot value, which is 4, is less than list2 dot value, which is 3. No, false, right? Because 3 is smaller. So we comes to else part. We say temp dot next is equal to list2. So now temp is already here. Temp dot next is coming from list2. So 3 is the next element. Then we do the same procedure. List2 is equal to list2 dot next. So list2 moves till 4. Temp moves ahead. Temp is now at 3. Right? Again, next comparison comes. List1 dot value is less than list2 dot value. 4 is less than 4. No. We come to else part. Right? In else part, again, temp dot next is equal to list2. So temp will get the item from the list2, 4. So it shows 4 here in red color, but yeah, this 4 is coming here. It's the same thing for us, but this 4 comes from list2. Temp list2 moves till next. So list2 has reached the null. Now list2 is null, and temp is equal to temp dot next. So temp moved till this 4. Now when the while condition is checked again, list2 is now null, right? But there is one element left in list1 which has not been included here. So this loop ends. We come here, temp dot next is equal to list1 is not equal to null. That is true, list1 is not null. So we'll say temp dot next is list1. So temp's next comes from this 4. Now complete list 1 1 2 3 4 4 is formed. And now we want to return the head of the list, right? This in the first stage was actually temp was before this. So temp dot next was pointing to this first node, and list was pointing to temp. So we return list dot next. Hope that makes sense. Let's test it quickly. If this still comes out as a confusion, please let me know in the comment section so that I'll upload a video on the linked list as well. Though I'll be doing that later on already, but if you get any confusion in understanding this solution, please comment in the comment section. I'll be happy to explain. Okay, so it's running fine. Let's submit. Okay, time complexity is great. Can anyone guess what is the time complexity for this problem? I know in this I have mentioned O of n, but no, this is not O of n actually. Time complexity for this problem, you can consider O of n, but it is O of n plus m. So we are going in one linear fashion, so O of n is valid. But if list 1 is this long, O of n, and then O of m, because we are covering both the lists. But after the second step, after the last step, when any one of the list is not null or it is completed, we are simply going to add the rest of the nodes from the other list, right? So we are going to actually go as far as shorter of the list into 2. So O, let's say the length is, let me cover here, let's say this length is n and this length is m. We covered till 4, 1 2 4 4, and this is actually O of m plus m again, right? O of 2m, and this we are not traversing, right? We are just traversing once. If this length was, let's say, m, this length was n, we covered n nodes and then n nodes, so 2n nodes in total, right? 2n. After that we just simply added the last few element, that would be 2n plus O of 1, O of 1, which is actually equal to O of 2n, which is same as O of n. Hence the overall time complexity of the problem comes to O of n. And with that done, let's mark the merge to sorted list problem solved. Oops. Okay, that's all from this video today. Thank you everyone. If you have any comments, please let me know in the comment section, and please like, share and subscribe. Thank you.